As I mentioned, you guys want to change the title of your notes to 2.1 instead of 1.6. I decided to make this part of our second unit instead of our first.
Wait, what?
Now this whole unit is gonna be a little bit of a hodgepodge. Hodgepodge means a mixture of topics. We're gonna talk about three big topics here. We're gonna talk about systems of equations. That's what the first few days will be about. And then we're gonna talk about functions. You know, what is a function and what does that mean? And then after that, we're going to start talking about transformation. That might be a new word for you. But Unit 2 is going to be kind of like a mixture of topics. Today, like I said, we're focusing on what is a system of equations, how can you find the solution. Specifically, we're going to be using graphing to do that. We'll try to squeeze in the inequalities as well if we get a chance. So, what's up, Mr. All right, here we go. So, suppose that there are two numbers between 0 and 10. You don't need to write this. Now, these two numbers add up to make 10. What are some possible values? Go ahead, Henry.
7 and 3.
So 7 and 3?
Yeah. Well, 7 plus 3.
What else?
5 and 5.
Kamos.
6 and 4.
2 and 8.
1 and 9.
Oh,
0
oops.
and 10.
There's a lot, right? Okay, there's more than one answer. So there's a lot of ways that we could take one number and add it to another number and get 10. There's a lot of ways, right? All right, let's move on here. Suppose there are two numbers between 0 and 10, and when you subtract them, they make 2. What are some ways that can happen? Go ahead, Chris. 5 minus 3? Kamos.
8 minus 6.
Good.
9 minus
All right, thank you.
7 minus 5.
Good, yeah, there's a bunch, right? There's a lot of ways. Now, here's another question. There's a lot of ways two numbers can make 10. There's a lot of ways two numbers can make 2, but what two numbers will do both of those things?
Wait, suppose
This is 2.1. Can you guys think of two numbers that would add up to make 10? 6 and 4? So the question is, which two numbers can add to make 10 and subtract to make 2? And Mike has said 6 and 4, is he right?
8. Oh, no.
Okay. Well, this is a system of equations. We have two equations, right? And we want to find the pair of numbers that work for both equations at the same time. Now, guessing and checking is awesome with an example like this, but whenever we're on our cell phone, we have a really hard time learning, especially if we're eating a sucker at the same time. That's a kind of a consequence too. All right, so anyway, back to math here. So guessing and checking is not always the best way to find the solution because sometimes you just can't get the answer that way. It's just too tedious. This one was. We're going to learn three ways to solve systems of equations in here to find the two numbers that work for both equations. One way is by graphing. That's today. Another way is with something called substitution and elimination. Is this ringing a bell from Algebra 1? Okay. Yeah. All right, so what is a system of equations? It's basically a set of two or more equations. There's an example. I believe I printed that for you, right?
Yeah.
Okay. What does it mean to find the solution? It means to find the x and y that work for both, right? So that's the example we had at the opener there. And the answer was 6 and 4. So if you have two equations with two variables, then your answer will have two numbers to it, right? And so that's what it means to solve it. And I don't think we need to do this because Mike already found us the solution. But I guess we'll do it anyway. We'll do it anyway. So let's call this the x-axis and this the y-axis, right? And I think I printed this for you guys.
Yeah. Yes.
So I'm just going to label this 1 through 10 on the x and y axis. So you guys came up with a lot of ways that two numbers can make 10, right? 9 and 1 made 10 when you add them up, right? So let's put that on there. When x is 1, y is 9. Oops, I made it 10. When x is 1, y is 9. We could do the flip of that too. What if I made the y equal to 9 and the x equal to 1? You could do that also. Or how about 2, 8? when x is 2, y is 8, that also makes 9. And then we could plot all those points. And we're going to end up with a line, right? And there's our line. That line consists of all the possible answers. Now, when I asked you guys to tell me the two numbers, you guys told me things like 2 and 8. But nobody thought of like 2.5 and 7.5.
That's what I was gonna say.
You could. And the line tells you every possible point. So somewhere on this line, there is a 2.5 and 7.5 combination. So it's got every possible combination to think of. Now let's look over here at this. We also had this one. The two numbers also subtract to make 2, right? So one answer is 10 and 8. 10 minus 8 makes 2, right?
Yeah.
So when x is 10, y was 8, right? Or how about when x is 9, y is 7? Probably right about here. 5, 6, 7. All right, 7, 5. My graph's not very perfect. But once again, we're going to draw a line and connect those dots, right? What was the answer to this problem?
6 and 4.
Let's find that point on the graph. Over 6, up 4. What do you notice about that point?
Whoa, you're a genius.
Where they cross, right? Why? Because that point works for both equations. Therefore, that point is on both lines. And therefore, that's the point where they cross. So today, we're going to be solving systems of equations by graphing. And the way you do that is you graph the lines, and you see where they cross. That's how you can find the solution, by graphing. So that's our task for today. Bueno? All right. Now, there are really two possibilities that we really kind of care about. Here's one. When they cross, you have an answer, right? Every point that exists has an x value and a y value, so you get one answer for x, you get one answer for y. So when they cross, you have, the fancy word for that is a consistent solution, okay? But if you have two lines that are actually parallel, then they don't cross, which means guess what? No solution. Those two equations could never have an x and y that will work for both. It's not possible. Anybody who have geometry yet? A couple of you? Okay, so for you algebra people, I don't know if algebra people know this or not, because I don't know what they teach you in middle school or what, but you guys know that means parallel, right? Anybody know? That means parallel. So in this case, those lines are parallel, so parallel lines have no solution when you're talking about systems of equations.
Like they would never touch, right? They just kind of constantly ride.
Yeah. Well, they don't get closer and closer either. They're always the same distance apart.
Oh.
That's parallel line. You're thinking of another idea in math where two lines do get closer and closer, but they never touch. That's called an asymptote.
That drives me nuts how they keep getting close so close.
Where did you, oh, that's right. You guys talked about exponents last year in Algebra 1, didn't you? Yeah, exponential functions have that. It's called an asymptote. All right. Anyway, this one here is infinite solutions. And all this, I don't really like this one because basically it just means you have the same line twice. So if you graphed it, you're going to have really just one line.
Yeah.
Now that might seem stupid. So when you're graphing, it seems stupid. It's like it's the same line. So what that means is the two lines you have are actually one line. Therefore, there's really an infinite number of solutions. When you're using substitution and elimination, it's not as stupid. It's actually kind of helpful to be aware of this. But with graphing, it's kind of like, well, duh, it's everything. They have all points in common. But we'll leave it at that for now. Let's move along. So we're going to get to practice some graphing here. And so here's the thing about graphing, solving a system by graphing, is that graphing is not a very precise way to solve a system because it depends on two things. First of all, what if it's not a nice answer? Like, what if it's like 3.26? Can you find that number on a graph? Not really, right? That's one shortcoming of the graphing method. The other shortcoming is how precise are you being when you graph? Because if your lines are slightly off, then you're not gonna. It's gonna look like they're crossing somewhere they're not. Matter of fact, when I did that example earlier with the x plus y equals 10 and x minus y equals 2, I was kind of worried they weren't gonna meet at 6, 4. I thought that'd be kind of messy. but they did pretty good. So we're going to be getting answers that should be pretty close today to the right answer, but it's kind of hard to tell if they're exactly right. And also, you want to be neat. So when you draw your lines today, make the lines straight if you can, because they're crooked and messy, you're going to miss it. So, but on the back, I provide you with graph paper. It's really hard to get the solutions to a system of equations by graphing if you're not using graph paper. It's very difficult. So,
Thank you.
yours is on the back. Yeah, he got the single-sided sheet. Everybody else got the double-sided. All right, so we're going to go ahead and begin here. Did I print these for you? 1 through 3?
No,
It's just the graph.
So why don't you guys do me a favor, on your graphs for numbers 1 through 3, would you guys write down those 3 systems of equations right above each graph there? And I'm going to pull up a piece of graph paper for myself so that when I graph them, they'll turn out nice too. What?
I need a sharpen my pencil.
I have a one over there under the bathroom pass. I also have a handheld one. What would you like? You look like more satisfied with mine.
That's what you have?
You're welcome. What? My nose doesn't work? That's ridiculous. I could smell you as soon as you got in the room. Wah, wah.
Mr. Bear.
Thanks, dude, for bringing it back to me.
So I have to use this.
You're a nice girl. You can use that. So this doesn't work?
You don't have to try yourself, I guess.
What do you think? I was like captain of the football team.
When I was
No,
in
no,
first
we're
grade,
like,
I
that's
was-
good.
Hey, what's up? Yes, of course. Just put your name on the whiteboard over there and take the green pass. All right. So let's do example. I'm going to need some help here with remembering what these are. All right. So I am going to ask Adrian to tell me what were the equations for number 1.
Y equals 3x
Uh-huh.
minus 2.
-2. And the other one?
Y equals negative 1
Oh,
over 2.
dang it.
1 over -1/2
X plus 5.
plus 5. Okay, so we get to review graphing a little bit. You lucky dogs. All right, so I'm going to do this one in red. We'll do the other one in green. So here we go. So I start at what? At your y-intercept of -2, right? So we're going to put a dot at -2. And then I'm going to go up how far? Good. Up 3 and right 1. So rise 3 over 1. Now if you want to make some really straight lines or straighter, you can use like a ruler or your ID. But you can also just keep doing the slope over and over again. So check this out. You can go over 1 up 3. Guess what? Just do it again. Right? You can also go backwards. And that way you have more dots to connect. And your line will come out a little bit nicer looking. There you go. So you can just keep doing the slope over and over again if you want. Or you can just use a straight edge, like a top of your ID or a ruler or something like that.
Oh, no. I just won't go.
Yeah. Do a little. All right. Let's go ahead and do the next one. Where do we start? I'm going to use my cards. You got time. I'm going to get my cards out. I haven't started number 2 yet. I'm still on number 1. Kayla, Kayla, where do I start for my green line? At 5. So let's all put a dot at 5. And then from there, I'm going to ask Natalie, where do I go from there? So I started at 5. Now where do I go to graph my line?
You go down,
Blah.
down.
Bro. Down.
You go down.
And yeah, so we go, the negative means we go down, and we go down 1, and we're going to go right 2. So starting from the 5, we go down 1, right 2. Oh, what do you know?
What?
Down 1, right 2. Down 1, right 2. They cross somewhere, don't they? And
That my lights don't look right.
I'm sorry.
okay, so now that point is the solution to the system. That point has the x and the y value, whereby if I were to plug in x and y there, it would work for both equations. Okay? So let's see what that x and y value is. Ready? How far over is that point?
2.
2. Now is it to the right 2 from the
Yes.
origin, or is it left 2?
Right.
So that's a positive 2. And it's up 4. And since it's up, is it a positive or negative?
Positive.
Okay, so this is my answer, but we can also write our answer like this. X equals 2, y equals 4. I think you guys should write your answer both ways, just so you know. So that is the point where if you plugged it in here, if you plugged in 2 for x, you would get 4. If you plugged in 2 here, you would also get 4. You found the pair of x and y that works for both equations.
What would you write?
It doesn't matter to me on the quiz, but I think you guys should be familiar with both ways of writing. So, any questions about number 1? All right, we get to repeat this process. You guys ready? So, let's move on to number 2. I'm going to ask Adrian again. Adrian, what were our equations for number 2?
4x minus 3y
Uh-huh.
equals 12.
Equals 12. And what else?
Y equals 3.
Y equals 3. Okay. So let's start off with something easy. Well, it's easy to do once you remember it, but remembering it's not always so easy. So let me ask somebody here. Javier, if I wanted to graph the line y equals 3, what would I do? I'm going to go to 3 on the y-axis, and so now what? It's a horizontal line, right? So let's draw that. That's nice. Right? Now, this guy here, the very first one, Alexis. What do we need to do here? There's something wrong here. Say that again? Say. Okay, we'll get there. We do need to do that. I'll give you some credit for that. Let me ask John here. We do. We want to get it in this form. Okay? We want to get it in that form. So we want to get the y by itself. So I'm going to stop you there, John, but I will get you credit for that one. I want to see if I can get some other people to help me out with it. Just a sec. Let me get John his credit here. All right. Let's see. All right, so Kiana. If I want to turn it into this form, I need to get y by itself. So what would you do first to get the y by itself? Multiply by what? -3? You could divide by a -3, but I like to do that step second. But I'll still get you a point for that. Let me see if I can have maybe Danielle. What would you do first, Danielle? You could do that. You could do that. I don't think I would do that, but you can. You can. I'm not going to go that route. What would you do, Joanna? I would move the 4x. Not that there's anything wrong with what you said, because that works. It's just, I like to do it this way myself. So I want to get y by itself, right? So the first thing I want to do is get the x term off of this side. So I'm going to subtract it, right? But whatever you do to one side, you have to do to the other. Can I combine these?
No.
No. So I'm going to just put plus 12 there on the side.
Oh, yeah.
Okay? And now I'm going to ask Heidi. Now what, Heidi? I want to get y by itself. What would you do to get y by itself? Huh? Divide it, right? We're going to divide everything by a -3. All right. Now here, I've got -4 over -3. What goes away?
The negative.
The negatives do, because a negative divided by a negative is a positive, right? And what's 12? Positive 12 divided by -3. Okay, now is this a little bit nicer to graph? No. There we go. So let's graph that. Nathaniel, where shall I go if I want to graph that?
I guess start with plotting the y-intercept, which would be -4.
Correct. -4 is my y-intercept. And then I'm going to ask Joanne again. Joanne, now what? Up 4 over 3. So from there, we're going to go up 4 over 3. This is going to be interesting. All right. Now, they're not touching it, right? So we want to keep going. So I'm going to go up 4 again and over 3 again. I went off my chart, so I'm going to estimate like right about there. Let's stretch it out. My lines don't touch. What does that mean?
I mean, can't they keep going?
There you go. I was trying to trick you. I was hoping somebody would say, no solution. But that's not true, right?
That's not what I said.
It is what you said. It's embarrassing. I'm embarrassed for you right now.
Isn't it across 5
Number one?
up,
You still number
up
1?
3? So that's where it is, right?
So we had to stretch it out. Sometimes when you're graphing these, you guys, they won't touch, but unless they're parallel, they're going to touch eventually, okay? So they do touch. So I had to stretch my lines out a little bit until they actually cross. Now let's find the coordinates. All right, so how far over to the right is my x value? How far up? There's your answer that works for both lines. That's the solution to the system. Yep, so x equals 5 and y equals 3. Which, by the way, we already knew y equals 3 at the very beginning, right? Yeah. Okay. Any questions? I'm going to assume Eric is smelling his desk. Does it smell good? Eric, you have a good, I appreciate you. You smile. Some kids get up and give me a dirty look after I say something. No, you're sweet. You're not mean either. All right, let's do one more. Let's do one more. Micah, give me the last equation.
Y equals 2x minus 5. And then the other one is y equals 2x plus 3.
Okay, they're both ready to be graphed, right?
That's it.
All right, so Jonathan,
Yes, sir.
I want to start by graphing this guy here. Where do I start?
Okay, we're going to start at -5.
-5.
Sir, you're missing anything.
Oh, did I do it wrong?
It's negative.
My bad.
Wait, did you do that on purpose?
No,
What are you doing?
I had a brain fart.
We all get points.
Oh, I thought you were doing it.
No, that was a mistake. All right, so now what, John?
Okay, and now, well, usually there would be a fraction of, there's not a fraction, so you're gonna make it over 1, which means you're gonna go up 2, and you're gonna go to the right 1.
Okay, I'm going to do that a few times because I like to have a bunch of points when I do systems of equations because the lines really need to be very straight and on point.
Wait, what?
Whoa, whoa, whoa. Hold on. You have a question, Hannah? So I started at 5. You good with that? And then I rose 2 and went over 1?
Oh, whatever one.
But no,
2.
2 over 1. Up 2 over 1. And then I did that a bunch of times. Up 2 over 1, up 2 over 1, up 2 over 1. Repeatedly. It just keeps going. We didn't do that before, but I'm doing that now because you want to be very precise with systems of
Because
equations.
our paper, it
Yeah, our
goes by
numbers are
2.
different.
It's by 2.
That's
so
why
you
it's
just-
confusing me.
Just go by half.
So you have to go between the
So your
numbers.
guys' graphs count by 2s.
Yeah.
You could relabel the numbers, or you can
I'm just not
just
even looking at
know
the
it goes by
numbers.
2s. That's at least I don't know, change them at least, so you don't want
So
to be
this is why
wrong.
my lines look all like.
Okay, thank you for pointing that out. I'm sorry, that is confusing. Sorry about that.
It is.
Let me ask Chris here. Chris, next one. Where do I start for this one? We start at 3, and then where do we go from there, Chris?
No, look at this one. This one. Like,
Up 2 over 1, right? And I can go backwards too, right? Instead of up and right, I can go down and left, down and left, down and left,
Parallel.
down and left.
where
It's
are
the
the
same
books?
slope.
You're right. These lines sure look parallel,
Not gone.
which means what?
No solution.
No solution. These two lines could never equal each other. That you'll never find an x and a y that will work in both equations. It's impossible. So we say no solution. Now, Micah, you knew right away that these were parallel. How did you know that? They have the same slope. When two lines have the same slope, they're parallel. So actually, you could get away with just looking at this being like, oh, they're parallel, no solution. You don't need to graph it at all. Okay, if you catch that in time. Okay. All right, so that is how you solve systems of equations by graphing. So let me throw a couple for you guys to do on your own here at you. So that's what the other blanks on your paper are for, so you guys can practice graphing a little bit. I don't want them just